Hi and welcome to DCO. My name is David Copetti, and in this video I'm sharing how to create this parametric door. I'll be showing all of the steps from creating the door frame, side rails, bottom, middle, and then inside panels using the steps here. We can change the door size, door height, and a lot of the details that you see in this model. At the end, we create kind of that inside form, and this is where this can go into a really complicated script. Now, overall, these are really straightforward steps, but from here, once you have a base form or a base script, you can actually take any portion and further develop it. What I mean is, there are many different center panels that can be created here and different ways in which they can be created. I only went through and used a loft command between curves, but you can also create a different type of segment and play around with the forms. So hopefully that makes sense. And then here you also have the ability to add more rails, because sometimes that is some details that you see in doors are different rails or different details inside with the inside of the door. A lot of the steps here you can use over and over for other doors and things like that. So it will be very useful if you've never used Grasshopper before. So hopefully that made sense and you're excited to learn how this works. And let's go ahead and jump right in. Let me get you up to date with the script that I'm creating here. I started with creating the door size. Let's go here. I'm going to just preview everything and show you. So what we're doing here is creating an overall door, and the door has side rails, it has a bottom, top rail, and a center rail. It also has sometimes a center division and then some details created on each side. So that's kind of the overall form that I'm creating. This is the overall door size. Here we have the door height. Next will be the side rail size. Now I actually am going over this again because I messed up on the last recording, because I actually went over all of these steps and I feel really bad that I didn't show it all correctly. So here we have the bottom rail. And now let's go here to the top rail. And the way that I created these was using this particular component called rectangle 2 points. So what I did was I extracted this point, moved it up using a vector, and this then creates this overall rectangle. Well, since I had already created the side rails here and here mirrored through the center, what happened was I used a region difference. So I subtracted the overall form from the side rails and did the same thing to the top. And all of them have a different slider. And so now we're back up to what I was showing before. So at this point we have these. Now we're going to create the center one. If the center one is the same size as these, then it's easy. But if you wanted to have a different size, well, then you would take the similar steps that you would take here, but have a size for the height that you're going to change. So to do that, let's go over the steps. This was a point that I extracted from when I moved the points to each side. And with this item, list item, we can take this point and move it up to where we want the center rail. So we'll go here to move and move this point in the Z direction. And for the factor, we'll plug in 36. Let's say that's going to be the height where it's going to go. Now we need to move this point to the right, positive X, and down, negative z. So we'll bring in a vector x, y, z, and now this is going to be the one that we want to plug in a negative value to bring it down, because or you can bring it up. Either way, you would take similar steps. So we can take this, move it in which direction? So we'll plug in the vector. It's going to be in the x direction, the door size. And technically, when we have so many going out like this, I like it coming out just out of one. That's the other thing that I was kind of sharing, is keeping this organized like this. Okay. So now we moved it to the right. Now we need to bring it down. We can technically do this in two separate components, but if we need to just do two movements, one way and then one down, we can use this XYZ vector. Now we need the Z component to be a negative value because we want it to go down, or at least I want to. And now the number is going to be the size. So we can pick that. So door height, if this is the top rail, bottom rail, this is called the lock rail, but we'll call this mid. So with these 2 points, that's all we need to create a rectangle. So we'll go here to rectangle 2 points and extrude, or plug in point A and point B. Now, as you can see, it doesn't work because it's asking us for a reference plane. And when you create a rectangle, it has to go on a reference plane. So this is why we created this base plane, that it has the overall shape, because we can use that as a reference plane. Now we can bring in a plane ourselves and use that as a reference plane, but it's better to use kind of that initial plane that you created, right? So let's go here to rectangle, and the next one is going to be similar to what we did here. Go to region difference, and this is what we want to keep, so that goes into A. We want to subtract the side rails, which are these two. I'll plug those into B. I'll hold down Shift and plug in an additional one. Now we can disable preview on all of this. This takes care of the height of the mid rail. And that's a basic detail of how a door can be. Now we have a center one to create, and we're going to take similar steps. Now, would you create it using this point? I wouldn't, because we have this initial point. Let's go here to move. We're going to move this initial point, which we have out of here, this relay. We're going to plug it, the motion is going to be the height of the door. Now we want to go to the left here and then down and to the right. And technically there are different ways of doing this. So let's just take this approach. We'll go here to move, and we'll move this in the X direction. The size that we want for the mid rail, or for technically this would be kind of like a mid rail too. But what happens is when you create something going off of the middle, you actually want to divide this by 2, because we're going to do the same amount in the opposite direction. This was in the positive direction. Now we need to do the same move. I'll copy this and you'll see that now I can do ×2, which would technically move it twice as much the other way, but we would actually do a negative value, which would get us back to where this one goes. So now we have these 2 points that move relative to that center point, and one of these points, it doesn't matter which one, we're going to move again down in the Z direction. And this time it's going to be negative by the same size as the door height. So we're going to bring one of those points down at 2 door size. Actually, door height. And I think, if I'm not mistaken, so just thinking out loud here, this is a door height. We can bring in the Z vector. We can skip the everything and bring that into a negative because it has to go down, and that will bring that down. So we can technically skip a few components, and with these two, let's bring in the rectangle. Rectangle 2 point, plug in A and plug in B, and also our base reference surface. Now with our center rail and top and bottom rail, we can subtract those. So we'll go here to region difference and subtract from curves A, all of these. Holding down shift will add all these inputs to subtract from that overall form. I'll disable the preview on this, and let's decrease the size here. And so now here at the center, we've basically taken up all of the space except for the center. So what we can do is bring in the outside curve of this plane. So we'll plug in that extrusion, and when it's a 2D plane, we can go here to curve, and it will actually give us the outside curve of that surface as one closed polyline. So now we can use this using region difference, keeping the overall rectangle and subtracting all of these. So let's make our way through our rectangles. And I think we're missing the top rail here. And this results with the overall rectangles that are on the inside. And so we're working in 2 dimensions because it's better to work in 2 dimensions first, then we can extrude into the 3D. The reason why is because the rails sometimes want to be a little bit thicker than the inside panels. And also we've only taken care of the door, where technically there would be also an outside frame, because this is going to be the door size, and then there's going to be a bit of a frame here at the bottom and at the top. So what we can do is do something similar, is move this point here to the left, and then move it up to the right, and then up and to the right a little bit. This way we can create a rectangle that we can subtract using this other polyline. So the theme for this one is mostly region difference, which is something that we tend to use a lot because it's super useful. So let's go here to the point, and we will move this in the negative Y direction or X direction. We'll do 1.500, which is a little bit too much, so we'll do 0.75. And actually, it's going to be this one, because that's the item that is the point that I want. So that works. Next, we're going to move this up and to the right. So we'll go here, move this point in a vector. It's going to be door height and door size. The door size is going to go in the X, and door height is going to go in the Z. Now we can take this point and move it once again. This time it's going to be moved using our vector XYZ, and our amount is going to be the same amount as, let's go here, as our frame size, X, and then Z. With these 2 points, now we can create the rectangle. And if you know that we need to use this as a reference plane, we can use this copy because it already has everything except for our points. Now we can use our initial point and then point B. Perfect. Now we can do, once again, region difference. So we'll use this rectangle for overall outside, and I choke a little bit because some of these are similar steps, but it's really, I think it's so cool when it's done parametrically here. Let's go to our curve, which is going to be, this goes to our curve, which is this one. That is what we want to subtract, but we don't want this one. Oops, I messed that up. We want this one. So now we have the outer frame, and we can disable the preview on all of this. Well, we're gonna need some of these points, maybe not. We will need that one. Okay, so I'm just hiding some of this stuff here. So we have our overall size. Here is the idea. This one will be extruded from the center out both sides. So we can move this one way or the other and then loft it and then cap, or we can just move it and then extrude it in one direction. Different ways of doing this. So the approach that I would do is, let's start with our outside frame. We'll go here to boundary surfaces, which will create a surface here. Now I can take this surface and move it using amplitude. We'll use, because it will extrude perpendicular to that surface. So I'll plug in that surface into the move, and the amplitude, the surface into the vector for the amplitude. Now we can give this a number. So we'll go to the size of the frame. We'll say 6.000. And since once again, we're doing it off of the center, we actually want to divide this by 2 because we'll be doing the other half for the other side. And then I'll go here to extrude. And here we'll go here to negative and then times 2. So multiply this by 2 in the negative direction. And we can plug this actually into our vector. So we are basically dividing the vector in 2 and doing a negative vector, which will keep this as our center and use this as the overall size. Let's go to all of this and disable preview. And here is the thing. Once we've created this portion of the script, which I think I have on my free portion of my website, we would take this and we would almost turn it into a cluster. But we can just group this because we know that this turns something into a solid. This is going to be frame thickness. We're going to do the same thing to the side panels. So we'll go here to the side rails first, this one and this one. Bring those both into a, well, technically we want to bring all of those into one component because they're all going to be extruded the same amount. We can go rectangle into this one and hold down shift and add additional inputs for the ones that I want to extrude at the same time. So now that I plugged all those in, let's go ahead and copy this and plug this in. This is going to be and now we'll do the same thing to the center. This time it's going to be a little bit less. So instead of 2, we'll do 1.5. Now that is a really simple door, right? It's almost like doing plywood on the inside. And there are other details that if you were into making doors, you'd probably add to this, right? One of them being, if we have the inside panel, sometimes they are grooved into the rails, and sometimes they have a different detail here, and we can also copy top, bottom, or whatever rail up here and create an additional panel. So those are things that we know we can do because for the most part we've been taking similar steps for all of this, right? And we can always add something else here and just use region difference. So I want to keep this. And so there's going to be panel. And I was thinking, what approach am I going to take for the panels? Because here we have this extruded panel, which is cool, but we also have the ability to do much more than that. What I mean is, if we take this and isolate that from everything else, so we'll take all of this and disable preview, and disable the preview on most of this stuff, and only show these. Now we know that I can also go here and just show the preview geometry, but we don't need to on this one. I want to show just with these. Now, what can we do? We can offset it to the inside. So we're going to create 2 offsets, and let me show you why. Offset, curve. And now it's offsetting the wrong curve because I plugged in the wrong curve. And let's go to a distance, which obviously it's going in the wrong direction. But that is what you would do if you were trying to create a group. So, but we're not doing that. So we'll go here to negative, and here towards, like, you know, when I'm doing a long tutorial, I feel like I might be losing you guys. So let me know if you have any questions. I want to go over any questions. I don't want anyone getting stuck on this stuff. So we'll go here to a negative value, and we'll change this to a specific number. So we'll go here to 1.500. This way we have a little bit of play with our offset. Next thing is we'll do that again. So I just copied that, and I'm copying this and adding this input. Now this we will move using amplitude. And we can plug in the center one to move. Now it's moving forward, and we actually want it to go backwards. I'll copy this, and we can label them in a second. So this becomes the hidden one. Now we're going to loft these together into a surface. This is a little bit too much. And so let's see if things are organized correctly, or if we have to do something different. Now we'll take this, and here is what will make it work for sure. Is I'll copy this and create a slider of 0, which means that this offsets by nothing, which is a little bit weird, but we'll make sure that all of these are using an offset component, which means that it will make sure that it works. So let me show it this way. We'll go to loft between this and this. So I'll hold down shift, and we've created that detail. Next, if I add, holding down shift, this one, and I graphed, it won't work, right? So I have to technically, let's see here, if I go to graphed tree, sometimes with graph tree it will work, and this is the reason why, is because it will organize the information correctly, and it tends to work. Loft options rather than normal, because I don't think, go to great, and then commit to changes. Yep. So what we'll do is it will unplug this last one, and what I'll do is I'll copy this, and rather than lofting those two, we'll loft these two. So what I'll do is I'm gonna have to copy this again, because it wants to come out of this one. Incorrect. It's going to be this one and this one. I guess the run around, and maybe I complicated it a little bit, I can probably optimize this a little bit more, is basically creating these two. Why? Because that would create the overall form, and if we have this base surface, we can now mirror this, or first move it to the right. So we have to take all of this, join it, brep join. And actually, let's take a look at those details because I think that's pretty cool. Let's go to here, disable preview or preview, and disable preview on all of this stuff. And let's actually hide the preview of the center panels. And this is what I wanted to show for the most part, is we can create panels like this. The other thing is, I think I mentioned this, these details can be created in different ways. I can also create a line here and create a parabola, create a graph mapper. You know, I can do all that stuff, but I think the idea is how to use this for anything, right? We can take any object and we can create it parametrically and basically use simple steps, right? We can always make them more complicated, but I feel like this kind of looks good. So now that we've joined this using brep join, I'll flatten the input. This way they all come in, the A values come in at once, and then here it says 4 different values because we have 4 different panels. So we'll take this and move it using amplitude. And I'll create it here and plug this surface in and bring in this vector down here. By default, it's going to do 1. We'll change this to 0.750 or 2.000. We can lower this. That's a little bit too much on that part, that detail coming in. So now that we've done that, let's take those and mirror them using mirror. And we'll use our original plane as our center plane. I'll disable the preview on everything because I want to show this next portion. Clearly. So now that we have these two and we've technically mirrored them to each side, now let's go here to brep edges and then brep edges on this one. And we'll plug those into curve just so I can show you that the naked curves will be the outside ones, and we'll do the same thing with these. We can loft those together. And actually, we don't want those inside because we have the inside ones here. So let me see. Okay, what we have to do is cap holes on this. If it does it to this one. does, but it has to create this. Okay, so this is what we have to do. I feel like there was another step that we had to do before. That was this one. And now, before we mirror it, and before we do all of this, we would take this and create the surface that's here. And that's actually super easy to create because we have this offset. And then this will be moved using the same move. So I'll go here to boundary surfaces, copy this down, and plug that in. Now we can do join brep, and this will make sure that you actually get the outside curve. And now let's see up here, we want to mirror this. And we will loft using graphed tree. Or actually, this is not being previewed, so that's probably why. And not curves, we'll go here to graphed. It's not going to work with that, so we'll go here to graph tree. Which will create that surface in between. So technically now we can join all of that together. Using brep join. And add all of those surfaces in. And disable the preview on all of this. And I'll go here to flatten. We've created 4 solid breps. And let's bring back everything else. Overall, that gets the details in. And I apologize in advance or after the fact if I confuse you a little bit. I will be sharing this under my script vault if you want to get a hold of it. And I'll probably optimize this very soon and have it on the script store. So I hope you learned something new watching this. I know I started a little bit late, but trust me, I'm probably more frustrated than you are. The fact that I went such a long time explaining most of the initial part, but I feel like I made up for it a little bit here towards the end because it's mostly the same steps. And down here, we have going to be at 0, so we don't move that. Here's what happens. If that's going to be at 0, I'll go to data item and I'll go here to 0. I don't want anyone moving that. And then if this is 0 also, I'll set that to 0. It's a little bit off screen on here. Now for this, we have our offset 1. This is how far in it goes. So we don't want it to go too deep, but enough to where it creates a nice detail. And then this is going to be the other panel. What I'll do now is I will bake it. So I'm just going to create a new layer. Technically, I just like to delete all of these layers. and then create a new one called door. We'll make that our layer and select all of this. I'll middle click, bake, and now let's take a look. Hopefully you found that useful. Let me know if you have any questions, like I said, and I hope to see you next time. If you'd like to get a hold of the script that I created for this video, check out my website, ComputationalDesign.com. There you can become a Script Vault member, where you can access all of the video scripts that I've created for my YouTube. You can access also the script store, where I have optimized scripts of all various kinds. And lastly, if you want to learn Grasshopper and you've never tried it, or you want to share that with someone, I have a 6-module course that will help anyone get started. I post videos like this that will teach people how to get started using Grasshopper, so make sure to subscribe for future content. I appreciate you being here, and I hope to see you next time.